our first presenter, which will be Luca. And while you start sharing your screen, I will give you a short introduction about Luca. So Luca is a research scientist at the Istituto Nazionale di Geofisica e Vulcanologia in Italy. His works focus on the study of modeling of irregularities of the Earth's ionosphere along the analysis and management of data collected from ground-based instruments such as GNSS receivers and ionosondes, and satellites for ionospheric research with a focus on space weather. Currently, he serves as vice president at the European Space Weather and Space Climate Association. And with that, the floor is yours, and we are looking forward to your presentation.
Thank you, Jan, and thanks for inviting me to give this into this very exciting workshop. I hope you can hear my voice. So I'm going to be your guide through this 20 minutes flight stride from the sun down to Earth to learn about space weather. So first of all, let's get into our definition of space weather. This is a definition which have been adopted by 24 European countries and the European Space Agency. So space weather is the physical and phenomenological state of natural space environment. There is an associated discipline which aims through observation, monitoring, analysis, modeling, at understanding and predicting the state of the sun, the interplanetary and planetary environments, the solar and non-solar driven perturbation that affect them, and also at forecasting and nowcasting the possible impacts on biological, on one side, and technological system. And here, there's this space weather definition in 15 languages. You may want to use it. So space weather is kind in between science and services, because you have to understand the state of the space environment while trying to predict, model, and mitigate the effect. And there are many aspects of the modern society which are affected by space weather events, starting from the radiation that we are here to discuss about it, for astronauts, crews on planes and satellites, but also effect at ground like degraded GNSS positioning, ground-induced current, degradation of telecommunication, and so on. You may see here a very nice picture from ESA, which summarizes all those kind of effects. So, and we are going to provide service. There is also need to have customized space weather services for specific customers and tailored to the particular application. And we report about a very peculiar case later in my talk. So let's start from the driver of all of this, which is our star, the sun. So Galileo was the first Western scientist which routinely observed the sun. Here you can see its original drawing from 1612, in which one important feature of the sun was revealed somehow with this approach. So the sun was rotating because those images, those pictures were taken at the very same time of each day, and those maculae, so those black spots, were drawn by Galileo himself, also ruined his sight to do this. So now we know if you are going to count day by day the number of those dark spots on the sun disks, we can get something like this. So those numbers change on a day-to-day basis, but on the average, you can recognize this kind of breadth of the sun, which goes from a maximum to a minimum number of sunspots along the years. And the periodicity of this maxima, among two maxima, is about 11 years. So somehow the sunspots, it's like a thermometer when we got fever. So it reveals something. But to understand what's happening to our body, we must understand and go deeper. But somehow it revealed the complexity of what's happening on the sun's surface. In fact, the sun is a dynamic star. If you look at different wavelengths of the sun under solar minimum and solar maximum condition, you may see that solar minimum conditions are characterized by a very quiet sun, okay? Also, by naked eye, you can recognize more turbulent and more dynamic structure under solar maximum conditions. So the sunspots, like the thermometer, I mean, reveal this complexity. And during solar maximum condition, there are many structures we can recognize, which is worth to investigate, and which are the principal driver of space weather phenomena. So those kind of feature we can recognize are the so-called loop. So sun is a plasma in a magnetized plasma. So there is a magnetic field in the sun. So we can recognize those loops, which are mostly plasma tube forming and climbing up along the invisible lines of the magnetic field of the sun. Then there are way bigger structures which are related to the so-called flux ropes, which are called prominences. And then we can recognize the most energetic events we have in the solar system, which are the so-called coronal mass ejections, which are explosion in the solar atmosphere with release of energy, mass, charged particles in the outer space. And we are talking about here to charged radiation going around on the spherical angle from sun. So besides this, there is also neutral radiation related to the flares activity. Those are intense explosion, releasing energy in the outer space, and they are in neutral radiation in the wavelength of X-rays, gamma rays, and radio waves. So under solar maximum condition, those phenomena are more likely to occur. Plus, there is some phenomena that occurs even under solar minimum condition. They are called coronal, and they are characterized by magnetic field lines which are open toward the space, and the sun can easily emit high-speed streams of particles from those coronal holes. However, in any case, the sun constantly emits mass, energy, particles on the spherical angle, creating an ultrasonic wind of plasma, which is called solar wind. And the solar wind affects the Earth thanks to our magnetic field, which is confined by the solar wind, creating the so-called magnetosphere. We have a shield thanks to that. Otherwise, the radiation would have been completely removed our atmosphere, making the life impossible as it was for Mars. We doesn't have a main field of our internal origin, but just a crustal field. Okay, and this is really it is really our shield, and it is very dynamically responding to the pressure of solar wind and related phenomena that are that surf the solar wind due to the solar explosion. Particular here, you may see that the interplanetary shocks, mostly driven by coronal mass ejection, can significantly modify the morphology of the magnetosphere and of the complex system of currents which circulate into the ionosphere magnetosphere system. Here you can see a couple of simulations of a storm of 2016, plus a reconstructed one of the worst space weather storm ever happened. And I will speak about it later in my slides. So you will see that there is different time response between the two events, and also different modification to which magnetosphere is exposed due to the forcing of the solar wind and of the interplanetary shocks during two solar events. So to summarize, these are the three main classes of solar phenomena which affect the geospace. On one hand, we have solar flares. They are UV and X-rays. They directly affect the upper atmosphere of the Earth. They travel at the speed of light, so after 8.3 minutes, they reach the Earth. Plus, there are coronal mass ejections, which affects the upper atmosphere through the coupling between solar wind magnetosphere and ionosphere thermosphere system. And depending on the velocity of the plasma, it takes between 1 and 3 days to reach the Earth. Plus, there is those fast protons and alpha particles, which again affect the upper atmosphere to the solar wind magnetosphere, ionosphere, thermosphere coupling. And depending again on the velocity, it can be between 15 minutes and few hours. So this is just to exemplify the complexity of the various superimposed phenomena that may reach the Earth with different timing and also with different means of detection from space and ground. I will not talk about detection but because of the 20 minutes, but it's an important part, of course, of the space weather monitoring. So while traveling to the Earth, those interplanetary shocks can reach the Earth. And if the magnetic configuration is favorable for magnetic reconduction, the magnetosphere opens to the injection of particles from the solar wind down the Earth. And they start to traveling along the field lines, changing the circulations and precipitating at auroral latitude and create the most beautiful side effects of space weather you may see here. So northern lights, aurora, and these are really the most beautiful and how to say marvelous effect of space weather. I've seen aurora, even if we live in Italy, during my travels because we manage instrumentation in Svalbard, and it is really something I miss every time. So I always willing to see auroras again. So to communicate the intensity of a storm, of an effect of solar storm on ground, we usually use the so-called space weather scale, which has been issued by the National Oceanic and Atmospheric Administration of the United States. And these are intended to communicate the severity of the space weather events in terms, for instance, of geomagnetic storms, so disturbances to the geomagnetic field induced at ground. And these are based on the physical measure, which is Kp. Kp is a kind of average disturbance of the horizontal component of the magnetic field recorded by a network of magnetometers located at subauroral latitudes. Here you can see the scale running from G1 to G5, so from minor to extreme conditions with different impacts on the various systems, including power systems, spacecraft operations, and other systems. And you can see also some average, very rough, approximate frequency per each solar cycle. And here you may see here an example of this Kp index running during a storm occurred more than 20 years ago, illustrating that a geomagnetic storm can have intensities varying along the lifetime of the storm with different intensities and lasting for several days. This is the typical time scale of a geomagnetic storm, several days. So beside this, there are also solar radiation storms and radio blackout. These are based on the flux of particles, mostly ions and X-rays measured by the GOES satellites, geostationary satellites. Again, you have 5 levels of intensity with different impacts on systems and different frequency. And here you can have 2 kind of examples of proton events on top and solar flare in terms of X-ray flux, as measured by the GOES satellites. It is a very old and historical event occurred in the Bastille. This is the Bastille Day event in year 2000. Of course, to make monitoring and to make prediction, there are also portals, services provided to the scientific community, but not only, also to the general public. Probably one of the most famous one is the Space Weather Prediction Center of the NOAA from US. Here you can see Here you can see all these current condition and forecasting for the three classes of storm I mentioned before. Also, Europe has its own one managed by the European Space Agency, in which many products are made available to the community. But to exemplify some kind of space weather effects, I'm going to report about some famous historical event. One of the most famous series of space weather events is the so-called Halloween storms, rather than storm, which occurred around the Halloween day in 2003. There was the strongest flare ever recorded in the modern area, which is a X45, which is a huge flare. And as you may see here from the bottom plot, the KP index, P stands for planetary, it's a global index. So the geomagnetic storm was very disturbed, it was severe for several days during the storm. These are a list of effects taken by a paper that was published at that time close to the occurrence of the storm. I would like to draw your attention on some of them. So for instance, the astronauts on the ISS went into the service module for radiation protection. There was a meaningful power system failure in Malmo in Sweden. The Mars Odyssey, which was flying to Mars, entered in the safe mode. In Wisconsin and New York area, there was high current levels in transmission lines. There was a changing, there was some prohibited routes north of 50 degrees latitude, and some rerouting what also happened, moving those planes, some of the planes towards south, and there was severe high latitude GPS receiver outages. Far in time, was a very famous event occurring in March 1989. This is known as the Quebec effect, because the effect of this geomagnetic storm was to induce the collapse of the grid company of the Hydro-Quebec, and 6 million people were left completely without electricity, as you may see here, for more than 9 hours. It was really a big problem. And also northern light, or maybe stable auroral arcs, which are not exactly auroras, were seen down to Texas and Caribbeans. I was mentioning before the strongest solar storm ever recorded by ground instruments. It happened in the 1859, so quite in a far era from the technological system, but enough developed to get meaningful space weather event. It is called also the Carrington event, named after Sir Richard Carrington. We had the fortune of studying the series of events which caused the effect. This again was the aurora reporting at that time, and with some reporting even from very low latitudes, Caribbean included. And this is the old magnetic record from the Royal Observatory of Greenwich, in which you may see on the left, I hope you can see my mouse, my pointer. Here you have the track of the depression of magnetic field going well beyond the scale of the magnetogram here. And some cases, the telegraphs continue to exchange messages even if they were disconnected from the power grid. And here, you can find it on Wikipedia. There is the conversation from two operators in Boston and Portland. We kept talking, even if disconnected, reporting even an excellent quality of the connection during the occurrence of the storm. Okay, it was a very far in time event, maybe rare, who cares? It happened in 2012. Luckily, the CME was not Earth directed, but a CME like the Carrington event was emitted by the sun, also in recent times. And in even recent more recent times, we had the most important event of the last 20 years since the Halloween storm was mentioned before. This is the Mother's Day series of space weather events occurring in May 2024. It is the largest geomagnetic storm in the last 20 years and really an unprecedented stress test for the space weather community. I was in the Space Weather Week conference in Coimbra last week, and there was 3 days of discussion about the effect, the preparedness of the community to this kind of event. It is definitely really exciting, while the last solar cycle was not so exciting at all. And here you may see the AR3664, which is the sunspot which caused the bulk of those events, which is both sides is comparable with the one causing the Carrington event. It was also very interesting because you may see on the top left the Earth, and these are on the center of the sun, these are the CMEs fired by the sun during these days. And if you see it again here, you may see several CMEs, a train of CMEs which reached the Earth and caused this very big and almost an ideal superstorm. There were many aurora reportings also over Italy. These are those we reported in the Space Weather Monitoring Group of INGV. And here you may see the displacement of the auroral oval, which reached also mid-latitude in Europe, which is a quite rare event. I'm going toward the conclusion. I would like just to report about the biggest customer ever of a space weather service in the history of space weather, which is a quite recent discipline, which is the International Civil Aviation Organization. So ICAO issue a bid for the provision of space weather service, and 4 centers, 4 consortia replied to the call, and actually they were all operating. They are shifting with each other on a 2 weeks basis. There is one European, mostly European, which is called Pegasus, in which Italy is and my institute is part of. There is Australia, Canada, France, and Japan. There is the Space Weather Prediction Center from US, and there is a China-Russian Federation Consortium, CRC, plus one regional center from the South African Space Agency. And it's quite a very interesting project because it is operational since 2019, and it aimed at translating, and it actually translates scientific information from instruments, data, models into advisory. So the last chain of this production is advisory, which arrives to the pilots, and it's part of the tools a pilot should have at least, to decide to take off or not. Here you may see this web page. There is the repository advisory, which is public, and these are divided into 3 big classes, which are of concern for civil aviation in terms of space weather effects. So HF communication, GNSS positioning, and radiation effects. And I'm going to conclude. I'm going toward the last slide, just to some piece of advertisement. As Ian mentioned, I'm the vice president of the European Space Weather and Space Climate Association, which runs 4 cornerstone activities of the international community, which are the medals, the Space Weather Week, the conference and journal, and recently the outreach and education activities. And we recently brought this book, and thank you for your attention, and I'm free to reply your questions.
Thank you, Luca. Very interesting presentation and a great insight about your activities and the space weather in general. Indeed, we received a couple of questions, and I think we still have time to forward them to you. So the first one would be, what tools were used for these simulation of influence from the sun to Earth's magnetosphere environments and with the movie visualizations?
Actually there are many. I honestly I don't remember exactly the one I use for those specific slides, but in the especially in the space weather in the ESA portal, there are also simulation of the propagation of CMEs towards the Earth. You may you may get so in the space weather portal of ESA.
Great, thank you. And then the other question would be, so your presentation was mainly focusing on the space weather that is being influenced by the sun or coming from the sun. And how much impact does other sources like from galactic cosmic rays coming from and impacting the space weather, and how do you deal with that?
I'm not completely an expert on this part, but of course, galactic cosmic rays plays a role also because space weather events cause the so-called Forbus decrease, which uh, has some impact on the systems. So for sure, this is part of the big cauldron of all the things that must be monitored and taken into account while providing a service, a space weather service tailored and customized for specific applications for sure.
Mm-hmm. Perfect, thank you.